Simplifying this algebraic expression, particularly when there's parentheses, the first thing you're always going to want to do is break apart the parentheses. Get everything on what I like to call the equal playing field, where there's no barriers between numbers. This parenthesis is kind of a barrier. Now, there's no number in front of this parenthesis, so I can assume there's a 1. And what can I do to break apart this parenthesis? Well, I can distribute the 1 onto each independent term inside the parenthesis. And when I do the distributive property, I'm actually multiplying. So let's go one by one. What is 1 times 4x? Just 4x. And now what's 1 times negative 5, right? Watch out for the pluses and minuses here. They are attached to the number. What's 1 times negative 5? Negative 5. And then I bring down the minus 2x. We've broken apart the parenthesis, and now we're on an equal level playing field. The 4x and the negative 2x, they are like terms. Why? Because they each have the exact same variable attached to it. The negative 5, he is an important part of the problem, but he's not actually going to change with the 4 or the negative 2, right? This negative 5 is its own term. It doesn't have an x with it. So the first step is to just isolate the like terms. Here we're lucky there's only one variable, just the x's. So I'm going to isolate the like terms and just do the math from left to right, also keeping in mind order of operations, with the like terms. So I have 4x minus 2x. Okay, that's another way of saying 4 minus 2, bring along the x. 2x, and then the 5 comes down. Now, unless we know what x is, this is it. That's as far as we go. That's our correct answer. Now, why? Well, because the 5 doesn't have an x with it. So that's as far as we can go to simplify it, right? They're not like terms. If that was x, we could then work with it some more. But since these are not like terms, that's as far as we can go. Let's do one more. 5x squared minus 3x plus 7x squared minus 4x plus 9, right? A lot going on, a lot of different like terms here. Okay, now it's important to keep in mind, just because you have the same variable, like x, the same exact kind of character here, or letter of the alphabet, doesn't necessarily mean you're a like term. And here's why. X squared is drastically different than x to the first power. So these are actually two different terms, right? A good rule of thumb is they have to be exactly the exact same variables to the exact same power in order to be a like term. So first step, like we did in the other problem, let's just identify what are all the like terms. Okay, well this 5x squared, well, I'm really only going to be looking for something else that has an x squared. So I'm going to go ahead and box this guy here. Now, who else has an x squared perfectly? This guy, right? Go ahead and bring the sign along with it, because that's going to play an important role. Okay, awesome. I did the x squared numbers. Let's use a different color here. Now let's look at the other type of like term, x to the first power. Right, so let's start from left to right. Here's my negative 3x. What is the like term to negative 3x? Negative 4x, because the x perfectly matches in both character, right? It's an x and exponent. And then the 9, he's the odd guy out. He can't simplify with anything, so he's just going to get dragged down at the end of it. So let's work. Let's start. Just focus on the red here. 5x squared plus 7x squared, right? It's going to give me 12x squared. Let's use black. 12x squared. Awesome. Now let's do the x to the first power like term. Negative 3x minus 4x. Just another way to think of it as negative 3 minus 4. Bring along the x. Negative 3 minus 4 is 7. Bring along the like term x. And then I'm going to bring down the 9. Okay, ask yourself, are we done, or is there any more work we can do? Unless we know what x is, we're done. X squared is not the same as x. And 9, he's got no x or no variable, so that's it. Thank you so much for watching. If you like this video, please share it with a friend who might need some help with simplifying expressions. Please rate this video a thumbs up, subscribe, and I'll see you in the next video.